Hey guys, Mr. Kyle Myers Mathematics, and let's just jump right into it. So, have you ever wondered what pi is? I mean, yeah, it's like three-ish, and it has to do with circles, and it's that number that you have to know, and there's like a button for it on the calculator. But what is it? Like, can we like express it in a way that like just uses like math things instead of the symbol pi? Like the square root of 2 is the thing that we can write as like 1 point blah 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 blah. So I kind of stumbled across this when I was tutoring, and I was tutoring at a like a math lab at a college, and it was slow that day. There wasn't really anybody in there, and I was thinking like, there's got to be a way to write pi as like an equation. There's got to be a way to like find out the number through like an equation of some kind. So I got to thinking like, okay, well, if pi has to do with a circle, right? So if pi has to do with a circle, so let's say we have this circle here. And we know, for instance, that area equals pi r squared, and the circumference is pi d, pi times diameter, then there's got to be a way to express pi using one of these things and figure out exactly what pi is using those things. So what I got to doing was I was like, okay, well, I mean, if you take a polygon, right, let's say like a triangle, let's say that's a equilateral triangle, and then you were to say, okay, well, what about a square? What about a pentagon? Or at least my attempt at a regular pentagon here. What about that? And then what if you just kept going? Right? Then eventually you would have so many sides that it would basically be a circle. So if we figure out what the pattern is in order to figure out what pi is, we could probably work something out there. That's kind of what my thought was, right? And so this actually ended up taking me like a while to figure this out, but I did it a while back, and I figured what I would do is I would kind of show you what I did and do it in much less time than several hours, hopefully only a few minutes here, but show you where pi, how you can write it as an equation and what I ended up doing. Just kind of a fun little experiment here. So what we would do is we would say, okay, well, we can either try to write the circumference and the diameter, or the area and the radius. I think I ended up doing the area and the radius, but I think it might be easier to do circumference and diameter. So what I'm thinking here is, if I divide both sides by d, then the circumference divided by the diameter equals pi. Okay. Well, so I can measure the diameter a couple different ways. I think the easiest way to measure the diameter would be to just go from the top to the bottom. So if I just go from top to bottom, or maybe from like corner to other corner. If I go from top to bottom, if I measure that, that would basically be the diameter, to go from the top to the bottom. So then what I can do is, well, you know what? That's probably not going to be the best way, because it changes. It changes. The diameter changes from going from like a corner to an edge, if it has an odd number of sides. And then it goes from the middle of the edge to the middle of the other edge, which is called the mid-segment. So that's probably not the best way to do it. And that's not what I ended up doing when I did this several years ago. What I actually ended up doing was, I actually ended up doing the area instead. So there's probably a way to do it, and I'm sure other people have done it that way. But what I ended up doing was, okay, what about area divided by r squared? Well, that would be pi. So all I need to do then is just find out what the area is. So I'm going to go ahead and rewrite these. So I've got a square, or sorry, a triangle, and then a square, and then a pentagon. That's a little bit better of a pentagon. To be fair, they're kind of hard to draw. I think the easiest way to draw it is actually to draw a star first, and then you know, shade in the things. But anyways, let's find out what the area is. Well, the area of a square is, well, you know, it's 1/2 base times height, right? Or sorry, area. I keep saying area of a square. Area of a triangle, and then area of a square is just side squared. Area of a pentagon, though, once we get to pentagons and beyond, we kind of have to use this other formula. 1/2 times the apothem times the perimeter. So if we do that, if we do 1/2 times the apothem times the perimeter, then we can actually set up something there. And you can actually use the same formula for the square and the triangle. So we don't have to use different formulas every time. And in fact, if we use the same formula every time, we'll see a pattern faster. 1/2 AP for all of them. So really, we could do this for all of them as well. 1/2 times the apothem times the perimeter would give you the area. Well, the perimeter of a circle is the circumference, which is equal to pi d. And then d over 2 is the radius. And then the apothem is kind of also the radius, so then it's radius squared. Anyways, if you do 1/2 AP for a circle, it ends up being 1/2 or pi r squared, funnily enough. But let's say we have a side. And by the way, the apothem is from the center, the segment that goes straight down to one of its sides. So that's A, that's the apothem. So it's basically already the radius. Right, so we can do that. And then what we can say is, okay, well, A is going to be different each time for all of these different shapes if they have different, you know, areas and radii and all that kind of stuff. And then the perimeter, we could figure out what the perimeter is. What we would need to do is say, okay, well, if I know the apothem, but I don't know the perimeter, you can actually figure out what the perimeter would be. And this is something that you learn in geometry, actually, when you're learning area and perimeter of shapes. One of the things you learn in geometry, especially honors geometry, you learn how to figure out what the area of a regular polygon is given only its apothem, or given only its perimeter. What of its side lengths, anything like that. So what we have to do is we have to say, okay, we need to figure out what this is. What this thing is right here. Well, there's actually a bunch of those. There's 1, 2, 3, 4, 5, 6 of these to be exact. And you'll find out that the pattern is that there's always twice as many of these little triangles you can make as there are sides. Right? So 1, 2, 3, 4, 5, 6, 7, 8. 8 of those. And what we want to do is we want to take this little triangle, kind of pop it out a little bit. It's not a very good rendering of it, but you get the picture. And we want to figure out what this side is, because if we can figure out what this bottom side is, S, then we can figure out what the whole perimeter was going to be. And we can actually know what this is. This is going to be, well, this is going to be a certain number of degrees. And actually we can figure out what it is, even though we don't know anything about the triangle. We can figure out what it is. We know that all of these angles have to add up to 360. Excuse me, it's a double hiccup. And if all the angles add up to 360, and there's 1, 2, 3, 4, 5, 6 of these triangles, and they're all the same triangle, then I would just divide 360 by 6. Okay, well, 36 over 6, that's 6, so it's 60 degrees. 60 degrees there, 60, 60, 60, 60, 60, 60, to add up to 360. So then that would make this 30. And that's a 30, 60, 90 triangle. So if I wanted to use special right triangles here, I could. But instead, what I'm going to do is I'm going to just use a ratio here. So the tangent of 60 degrees is equal to its opposite side, which I'm calling S, over its adjacent side, which I'm calling A. So then A, if I multiply A on both sides, I have A tangent 60 is equal to S. And then I'm going to have a certain number of those S's. In order to get the whole perimeter, because that's what I want the whole perimeter, I'm going to need 1, 2, 3, 4, 5, 6 of those. So I need 6 of these, so 6A tan 60 equals 6S. 6 of those sides equals the perimeter. So there we go, I have my equation. The area of this triangle is 1/2 times the apothem times the perimeter, which is 6A tan 60. And there we go. So you're going to find out that it's actually going to be the same thing as you go here. So if I do the same thing, I'm going to pop out this triangle here. Well, this angle right here, there's going to be 8 of them. So it would be 360 over 8. There's 8 of those little mini triangles, those red triangles. If I divide by 8, the trick to that is actually halving it 3 times. So take half 180, take half 90, take half 45. So this is 45 degrees. So this is 45, which means this is a 45, 45, 90 triangle. Or sorry, yeah, triangle. So if that's A, then A and S are actually the same thing. A and S are actually the same thing. So this is really just area equals 1/2 times the apothem. And then if I really wanted to, I could write this as tangent. The tangent of 45 degrees would be equal to, right, so tangent of 45 degrees equals opposite S over adjacent A. So A tan 45 is equal to one of the sides. I multiplied the side by 8 because there's 8 of those sides. 1, 2, 3, 4, 5, 6, 7, 8 to get the perimeter. So I multiply by 8. So 8A tan 45 is what I would multiply by. So you kind of see a pattern here, right? It's always going to be 1/2 times the apothem times either 6 or 8, A, and then tangent of something. And it seems like that something gets smaller each time. So actually what we can do is we can actually go ahead and look at the pattern and go ahead and figure out what it would be. So from here now, what we can do is we can say, okay, well, I know that the area is always going to be 1/2. And then there's always going to be that A. But then the next number is either a 6 or an 8. Well, it was 6 because it was a triangle, 8 because it was a square. So it's always going to be twice the number of sides. So 2 times the number of sides. And I kind of used S to represent half a side length. So I don't want to be confusing here, but I'm going to maybe use a capital S to represent the sides that the shape has. So capital S to represent the sides that a shape has. So 2 times capital S, and maybe let's use a cursive S so I don't get it confused with a 5 here. So 2S, 2 times the number of sides, times A, and then it's times the tangent of something. Well, tangent of what? The first time it was 60, second time it was 45. Well, how did we get 60 and how did we get 45? Let's go back up here. What we did was we took 360 and then divided it by twice the number of sides. So it's the tangent of 360 over twice the number of sides that it has. And there we go. We have an equation for the area. Now, if you haven't been wondering why, if you've been wondering why I'm finding a pattern here as we go along, it's because what I'm thinking of doing and what I thought of doing a few years back was if I kept going, if I kept making the sides bigger, if I kept making the number of sides bigger, right? So pentagon, 5 sides, hexagon, 6 sides. If S, the number of sides, gets larger, if S were to be infinity, if you kept going, you would eventually have an infinite number of sides, and it would turn into a perfect circle. So the only way to do that, though, is with this thing called a limit. So what we would do then is we would say, I want the limit as S approaches infinity of this, of all of this. And before we do that, what we need to do actually is we need to figure out what pi is, right? So we know what the area is. This is equal to the area. If that goes to infinity, if S is infinity, then it would equal pi r squared. So if the area, if S is infinity, then it would be pi r squared. So basically I can divide both sides by r squared, which r and a are going to be the same thing. So I can interchange a for r. And in fact, let me just write this as a maybe. A squared, the apothem squared. Because the apothem and the radius are the same thing if the number of sides goes to infinity. So then I have that. Okay. Well, then I can actually clean this up a little bit. 1/2 and 2, they cancel. And here's a squared. A, that's a squared. So that cancels with that. So really, it just boils down to the tangent of 360 over 2s. Well, 360 over 2, that's 180. So 180 over s. So the tangent of 180 over s, oh, and there's an s out front that I forgot about. So s tangent 180 over s would be equal to pi when it's going to infinity. So this is as it's going to infinity. So the limit as s approaches infinity, and that has to be what pi is. So actually, when you do this topic in geometry, this geometry topic would be under area and perimeter when you're finding the area of regular polygons. When you take a regular polygon formula, 1/2 AP, and then you actually create the formula for what happens when you don't have the perimeter, which would be 1/2 A and then 2s a tangent of 180 over s. When you take that formula and then you solve it for pi, you set it equal to the area of the the area of the circle formula, and then you solve it, what you get is a formula for pi itself. So if you were to take and plug this into a calculator, and go ahead and pause this if you'd like, and this is what you would do. You, on a graphing calculator, take and just use x. Go x tangent of 180 over x. Make sure it's in degree mode. Graph it. And then what you do is set your window to x starting at 0 and ending at, let's say, 1,000. And do a scale of 100 for x. Then for y's, since it's going to equal pi, you only need to go from about 0 to 5. Because it's going to be 3.1415, blah, 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 blah. So your y scale only needs to go from 0 to 5. If it's stuck from -10 to 10, like it normally is, you can actually just switch the -10 to a 0 and then just call it a day. 0 to 10 would be fine. I probably wouldn't go into the negatives because then it won't show it that well. So maybe just go from 0, y min 0, y max 5, y scale 1, graph it. And then what you do is just hit the trace button and go all the way out to the right as far as you can. Maybe right's that way. I forget which way right is whenever you actually replay this. But you would go out to the right as far as possible, and what you'll see is pi happens. This is the formula, the equation for pi. You can graph it, and as you go to infinity, it'll get closer and closer to pi. So I hope this video was helpful. If you have not already, I have a free guide called The 5 Math Mistakes Everyone Makes and How to Avoid Them. It's a free download on my website, myersmathematics.com, link in the description below. And of course, if you found this video helpful, give it a like. If you want to see more videos like this, subscribe. And if you have any questions about this video, how I did any of these steps, I'll go back up to the top here. If you have any questions about how I did any of these steps, or if you want to know more about how to solve for the area of a regular polygon and how to do that effectively, and any tricks and anything that might help with that topic, let me know in the comments below. And as of putting out this video, it is summertime, but so I just kind of figured I'd do something fun. But if you have any questions at all, if you have any questions about SAT, anything like that, let me know. I'm working on an SAT course, a little mini course. I think I'm going to do it for free. I think I'm just going to end up making it a free course. And that'll be kind of my new free thing, along with my 5 mistakes everyone makes and how to avoid them. Just kind of coming out with some like resources that I think will be helpful. So stay tuned for that. And as always, I will see you in another episode.